Welcome to section 9.1, polar coordinates. Today we're just going to look at polar coordinates and how we graph on the polar plane. In polar coordinates, the origin is called the pole, and the polar axis is an initial ray from the pole. It's usually where 0 degrees is on the unit circle, but we can have it oriented anywhere we want. Points are given as r, and then the angle measure of theta, where r is the distance from the pole, it's the radius, and the theta is the angle measurement from the polar axis. Let's see what that looks like. So first we're going to graph some points. We want to graph the point S, which is a radius of 1, the r is 1, and the 200 degrees. So with this, we go with our degree first. We're going to start at our normal 0 degree position. We're going to go counterclockwise to 200 degrees, which is a little bit closer to 210 than 180 degrees is. And we're going to go to radius 1. So we have a point that's roughly right here. All right, we're at radius 1, and we are at roughly 200 degrees, and we label this point. Then we have r, the point r of negative 2, 3 pi halves. So we are going to graph at 3 pi halves, and our radius is negative 2 this time, which means when we get to 3 pi halves, which is down here at the bottom, we are going to go backwards 2 units. So instead of being down toward the south at 270 degrees or 3 pi halves, we're going to go up to be right here. All right, that is negative 2 from 3 pi halves. We're going in the opposite direction, and we label this point R. Then we have the point M, which is 4, negative 90. So with this one, we're going to go backwards 90 degrees. We're going to go counterclockwise. So we're going this way now because we're going negative. And we're going to go negative 90 degrees and then a radius of 4, which is going to put us right there. And this is point M. And lastly, we're going to do point Q. Q is negative 240 degrees. I'm going to go backwards 240 degrees and a radius of negative 2. So again, we're going to go clockwise 240 degrees, which is at the same position as 120 degrees positive. And we're going to go backwards 2. So we're going to get up to this degree measure right here, and we're going back 2. So we just have to put our point right here. And we label this Q. So this is how we graph polar coordinates on a polar grid. So here it says to find 4 different pairs of polar coordinates that name the point S if we're between 360 degrees to 360 degrees positive. So we can go backwards or forwards. So the first thing I do is just do the normal angle measure. Well, we're at 210 degrees, and our radius here is at 2. So my first point is at 2 for my radius and 210 degrees for my angle measure. Another way to do this is to go backwards. Instead of going positive 210 degrees, we go backwards. Well, if you take 210 minus 360, you're going to get that this is the same point as 2 negative 150 degrees. We could also do this where this would be extended, right? So if we went to 30 degrees and did a negative 2 for our radius, we would end up in the same place. We could also go backwards from 0 all the way around and take 30 minus 360 to get negative 330 degrees, also going backwards 2. All right, so these are 4 different ways that we could identify the point S using the polar coordinate system. This is a little different than the rectangular coordinate system, where each point can only be identified by one ordered pair. Here we have different ways to identify a point. Next thing we're going to do is graph a polar equation where r is 2.5. All this is a circle of radius 2.5. Oh, got a little wide there. All right, so that's what we'd want to look at. Hopefully you guys can do a better job than what I just did. But that's what we're doing. We're drawing a circle of radius 2.5. Next thing we have is if we're graphing a polar equation, just theta is 5 pi 6. When we do this, we're going to look at where 5 pi 6 is on our circle. And this is basically a line at that angle, and it radiates both ways. So this is going to be a line like this. And it does have arrows on the ends. This is just a line that goes through the angle 5 pi 6, but it does go both ways. Last thing we're going to do is find the distance between points. And to find the distance between 2 points, we have this nice little formula derived from trigonometry. And we want to find the distance. We take the square root of the first radius squared plus the second radius squared minus 2 times radius 1, radius 2, cosine angle 2 minus angle 1. All right, so let's use this formula, and this is how we can find the distance between points. So here we have 2 points. We want to find the distance between them. We just set up our equation. The distance is the square root. The first radius we'll call A is our radius 1. It's 8 squared. Plus the second radius squared, which is 4. Minus 2 times the first radius times the second radius times the cosine. We'll take the second minus the first, so 300 minus 60. These are both in degrees, so make sure your calculator is in degrees when you do this. And we can put this all in our calculator at one time. You can, if you want, simplify the 300 minus 60 right away, or you can type it in your calculator that way. It's up to you. And we should get 10.58. And we are talking about miles, so this is 10.58 miles. That's our distance between our 2 points. Okay, we just plug it in our formula, use the formula, and away we go. That is all for section 9.1, the introduction to polar coordinates and how we plot points, graph equations, and find distances on the polar plane. Thank you for watching, and have a nice day.